Continuing with our review problems, a housing permit is authorization from a governing body to construct a privately owned housing unit. The data in the table below represents the number of housing permits issued from 2000 to 2009 in the United States. We want to construct a time series plot. You'll notice that I have already drawn my vertical axes and my horizontal axes. For a time series, the year goes along the horizontal axes, and so I've already put 2000, 2001, 2002, all the way up to 2009, each of the years. On the vertical axes, we want to put the number of permits. You'll notice I put in thousands. That way I could kind of skip around a little bit. So where I'm talking about in thousands, this one's approximately 1,500,000. A little more than 1,500,000, so 1,547. This one's 1,658. In other words, I'm taking off the hundreds is what I'm doing. So 1,776,000, 1,960,000, 207,000. Okay? So again, literally when I'm talking about thousands, I'm taking this off. You'll notice I've drawn a little squiggly line here. Recall that that squiggly line means that there's a break. I've cut out a chunk of the graph. Because I'll be honest, trying to go from 0 up to 2,100, even in thousands, it makes it very difficult to draw our graph or our scale on the vertical axes. So we're going to approximate. So in 2000 it was 1516, so approximately here. In 2001 it was 1547, so we're going to go up slightly. 2002 it was 1658, so we're approximately here. You'll notice that it is an approximation. 1776, 1960, 2007, 1713, so we're about here. 1304, so right about here. 841, that's going to come down here. And 543 is going to be approximately here. Again, it's a best guess. A time series is a line graph where I connect the dots. And so I'm going to connect all these dots. Okay. In what year was the number of housing permits issued highest? Well, we can either look at the graph or we can look at our table up here. Either way, it was in 2005. So in the year 2005, the number of housing permits issued was the highest. Again, this is that time series plot. Listed below are the ACT scores of 40, so that's my sample size, n is equal to 40, randomly selected students at a major university. They have a 32, a 16, 11, and so forth. Construct a grouped frequency distribution. That means that we're going to have classes. And a cumulative frequency distribution just means we're adding that cumulative frequency column. We want to use 5 classes with the first lower limit starting at 11. So I'm going to start right here at 11. State the midpoints of each class. Round the relative frequencies to the nearest thousandth 3 decimals. So that's 3 decimals. Okay, I've got to first find my class width. I can't just estimate or anything. So I need to find my smallest number, which is 11. Kind of gives it to us in the problem. And then I need to find my highest number. So here's a 32. Do I have anything larger than a 32? No. So I'm going to have 32 minus 11, and we want 5 classes. So I divide by 5. 32 minus 11 is 21. Divided by 5 gives me 4.2. Since we are discussing whole numbers. Our data is in whole numbers. I'm going to round up to the next whole number here, which is going to be 5. Recall that whenever I find my class width, I add it down, not across. So 11 plus 5 gives me 16. 16 plus 5 gives me 21. 21 plus 5 gives me 26. 26 plus 5 gives me 31. Then I need to find my upper class limits. If this one begins at 16, this one is going to end at 15.9. This one begins at 21, so this one will end at 20.5. We begin at 26, so we end at 25.9. We begin at 30, so we end at 30.9. To get this last one here, notice I added 5 down. I'm going to add 5 down, and I get 35.9. Now I need to calculate the midpoint. The midpoint is the lower limit plus the next lower limit divided by 2. So 11 plus 16 divided by 2. And I get 13.5. So the first lower limit is 13.5. Same thing that I've done here, I've added 5 down. I can add 5 down here as well, or I can do the calculation, whichever is easiest for you. Either way works. And so I should get 33.5 as my last midpoint. Now I need to find my frequency. I need to add up how many belong in this particular class from 11 to 15.9, and then do the same thing for each other one. In a lot of ways, doing the tally marks are the easiest for me, so I'd highly recommend that you pause the video, find your frequency, and then come back and check. So hopefully you paused the video and got the same numbers that I did, 9, 14, 12, 4, and 1. Now we need to get the relative frequency. Remember that the relative frequency is the frequency divided by the total, and it told us that we had 40, so hopefully if we add this up it does have 40. So I'm going to take 9 divided by 40, and I'm going to round to 3 decimal places, so that's 0.225. 14 divided by 40, rounded to 3 decimal places, is 0.350. Then we get 0.300 because we took 12 and divided by 40. Going to take 4 divided by 40 and get 0.100. 1 divided by 40 gives us 0.025. This right here should add up as close to 1 as possible. You may be off in like the 3rd decimal place or something, which is okay. It's the rounding issues that you might realize that you're off. Cumulative frequency. Remember, the first frequency comes over as our beginning frequency. Then I'm going to take 9 plus 14, which will give me 23. I take 23 plus 12, which gives me 35. 35 plus 4, which gives me 39. 39 plus 1 gives me 40. This number and this number should be the exact same. We wanted to do this frequency distribution so that we could make a frequency polygon. Recall that a frequency polygon is a line graph that uses the frequency along the vertical axes, and it uses the midpoints down here. I'm still going to label this ACT scores because that's what we are discussing, but I'm going to put the midpoints down here. So my midpoints were 13.5. We had one at 18.5, 23.5, 28.5, and 33.5. These were our midpoints. Now the frequencies go anywhere from 1, 7, 8, 9, 10, 11, 12, 13, 14, 15. because it goes from 1 to 14. So I'm going to say here's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And this way you can see that this one's a 1, 2, 3 type thing. So at 13.5, we had a frequency of 9. So I'm going to come up to 9. At 18.5, we had the frequency of 14. At 23.5, we had a frequency of 12. 28.5, we had a frequency of 4. And then 33.5, we had a frequency of 1. And we connect our dots. So we have created a frequency polygon. The last thing that we want to do on this particular problem is construct an ogive. Remember that an ogive uses the cumulative frequency along the vertical axis, so the cumulative frequency, and then we use the upper limits here. So our upper limits were at 15.9, 20.9, 25.9, 30.9, and 35.9. We are still talking ACT scores, so I'm still going to label this as ACT scores. My cumulative frequency went from 0 to 40. So I'm going to 5, 10, 15, 20, 25, 30, 35, 40. I'm going to count by 5s. I can go back in and fill in with 1s if I wanted to. That just makes it much more difficult to read. A frequency ogive is a line graph. So we're going to use that cumulative frequency that's here. So we're going to use the numbers 9, 23, 35, 39, and 40. So at 15.9, we were at 9. At 20.9, we went up to 23. At 25.9, we were at 35. At 30.9, we were at 39. And at 30.5. 35.9, we were at 40. And I draw my line graph. And you'll notice that it's constantly increasing. It never decreases. That's the biggest thing about an ogive. So go ahead and practice a few more of these, and then let me know if you have any questions.